Okay, so the last one we need to go over from the harder problems with acceleration sheet is number 6. So 6 says a skydiver leaves a plane at an altitude of 3,000 meters, and the diver free falls for 6 seconds before opening her parachute. Because of air resistance, the diver experiences an acceleration of only 8 meters per second squared, as opposed to the 9.81. As the parachute fills with air, the diver is slowed down to 5 meters per second in 10 seconds. If the diver continues falling at this speed for the rest of the dive, how long will it take the diver to reach the ground after leaving the plane? Okay, so go back and reread it and pick out how many sections are in it. If you do, you should find 3. Okay, so the first section is before the parachute opens in what we would call free fall. Okay, the second section is parachute opening. And the third section is after the parachute is opening when she falls at a constant speed to the ground. Okay? So, free fall. Leaves the plane at an altitude. Now, the altitude is 3,000 meters. So, it's telling us this whole thing from the top when she steps out of the plane and to the bottom where she hits the ground. The whole thing is 3,000 meters. Okay? So, she steps out of the plane. She doesn't jump. So, her VI is 0. It says she falls for 6 seconds before she pulls the cord, because that feeling of just falling is kind of cool if you don't die of a heart attack first. And the acceleration is not 9.81 meters per second squared this time. It's only 8 because of air resistance. Okay, so that's in the first section. In the second section, it says, as the parachute fills with air, she is slowed down. So we don't know, this is the slowing down section then. And we don't know what her initial speed is in this section. But it's going to be whatever her final was up here. So once you find her final, that will become her initial down here. Okay, as it fills with air, she slows down to a speed. Her VF will be 5 meters per second down. And she's in this section. She slows down for 10 seconds. Okay? Then she hits a constant speed. And it says she continues falling at this speed for the rest of the dive. At what speed? At the speed that was her final speed up here. So the 5 meters per second down. For the rest of the dive. We don't know what delta D3 is, but we'll be able to find it. And we don't know delta T3. So the question wants to know how long. So you need the time for each section. We have delta T1, we have delta T2, so really all we need to find is delta T3. But to get delta T3, we need delta D3. We need the distance of this section. And the distance of this section will be 3,000 meters, the whole distance, minus delta D1 plus delta D2. So really, up here we need to find delta D2, and we need to find delta D1. And then once we have those, we can solve. Okay, so start out in the first section. We can find both our VF and our delta D1. So delta D1 is just going to be VI delta T plus 1/2 A delta T squared. This will go to 0. So delta D1 is going to be 1/2. A is 8 meters per second squared, and it told us 6 seconds squared. 6 squared is 36. Half of 8 is 4. 4 times 36, 144 meters. This is D1. Now we need VF to be able to get VI, so you could either do VF squared equals VI squared plus 2A delta D, but if you got this delta D wrong, that's dangerous. So I would probably do A equals VF minus VI over delta T, simply because they gave us the VI, the A, and the delta T. So the VI is 0. We're solving for VF, multiply both sides by delta T. So VF is going to be equal to 8 meters per second times 6 seconds. VF is 48 meters per second. And so that means our VI is 48 meters per second. So once we have that, now we can get our delta D2, or we can move at least to the next section. Now, this section has an acceleration, which we don't know, but that we can find. A2 will just be equal to VF minus VI over delta T. So A2 will be equal to 5 meters per second minus 48 meters per second divided by 10 seconds. On the top you get negative 43, divide that by 10, negative 4.3 meters per second squared. Okay? Once you have this, you can now get your D2. So, and the negative means, of course, slowing down. In other words, up. So delta D2, I'd probably do VI delta T plus 1/2 A delta T squared. So D2 is equal to 45 meters per second times 10 seconds plus 1/2, 4.3 meters per second squared times 10 seconds squared. So delta D2 is equal to, the first term is going to be 400, oh sorry, that's 8, 400, let me make that bigger, 480 meters minus 10 squared is 100, 430, and take half of that should be 215 meters. And so delta D2, when you subtract, should be 265 meters. So we have our D2. Now that we have our D2, we can find our D3. D3 is just equal to 3,000 meters minus, bracket, 144 meters plus 265, because it tells us in the question the whole thing is 3,000 meters. So D2 is going to be 2591 meters. Okay? Once we have that, we can find our T3, because we know VF is equal to delta D over delta T. So delta T3 will equal delta D3 over VF. So delta T3 will equal 2591 meters divided by 5 meters per second. And so we will get a T3 of 518.2 seconds. So now the question wants the full time, so T total should be equal to T1 plus T2 plus T3. So T total will equal 6 seconds plus 10 seconds, that's 16, plus 518 should be 534.2 seconds. We are done. Okay, so now it's time to practice some more. I want you to do on the last of the acceleration sheet, 4 and 5. They're the only ones you have left on that one. And then I want you to take this sheet that you got in class the last time I saw you. And on the side, okay, so maybe a few more kinematics questions for just for fun. How about 1, 2, and 3? Okay, so okay, maybe not the back side. Not the side that says it seems wrong to waste the back of his sheet. But okay, so maybe a few more just for fun. 1, 2, and 3. Thank you.